This will be Geometry Lesson 3.3 and 3.4. They cover pretty much the same stuff. 3.4 just deals with what happens when we have parallel lines. But we're going to get our other four angle relationships that we've been talking about. We've talked about two of them so far, vertical angles and linear pair. Today we're going to get the other four of the six I said we were going to have. So lines and their transversals. We know what lines are. First off, we need to define what a transversal is. A transversal in geometry is a line that intersects two or more coplanar lines. Okay, so you can pause this video and go ahead and get that definition down. So it's a line that intersects two or more coplanar lines. Pause the video, get that definition down. Alright, so draw a transversal on the drawing to measure all the angles. So if we draw a transversal right here and we start measuring angles, what we would find is we'd measure this up here. Let's say this guy is 70 degrees. Now we can use our two angle relationships that we already know. If this would be 70, this guy over here would be 70 degrees. And then these two would be 110. That's using our vertical angles and our linear pair postulate. 180 minus 70 is 110, so we could do those calculations without even measuring those. Now the thing is just because we measure one up here doesn't mean we know anything about these guys down here yet. So what we'd have to do is we'd have to come down here, measure another angle. Maybe this guy's 60. Vertical angles would mean that this guy's 60. Then we could use that linear pair postulate to say, hey, 180 minus 60 is 120. And then we could do vertical angles again this way, or we could look at linear pair postulate this way. So that's what happens when we draw two lines and then we transverse those with a third line. Now if we label these A, B, and C, C would be the transversal that we were looking at. Now if I ask you this question, would B be a transversal? Well, if we go way out here, is B sooner or later going to intersect A? Yes. So B would be a line that would intersect two other lines as well. So B and A would also both be transversals, but we're not too worried about that right now. All right. So let's go to the next drawing here. We have our definition of transversal. So now what we need to do is look at some of these relationships that happens within these. So now what I want you to do is I want you to label these angles the same way I do. Starting in the top left corner, I'm going to go 1 to the right, 2, back to the left, 3, 4, 5, 6, 7, and 8. So you need to have those labeled exactly like I labeled those. Now what we're going to do is here's our four new angle relationships. Corresponding angles. Now corresponding angles, sorry to define a word with a word, but corresponding angles are angles that occupy corresponding positions or the same. So corresponding and underneath I'm going to put the same position. Okay. So they occupy corresponding positions. So if we go up here, now what we could do is we have our two old school relationships. You know, we have 2 and 3 are vertical angles. 1 and 4 are vertical angles. 1 and 2 are linear pair. 2 and 4 are linear pair. But what we're doing this chapter is we're going to compare these guys up here with these guys down here. All right, so that's what we're looking at doing. We're going to compare the guys that are up here at this point of intersection to these guys down here and come up with relationships there. So if we go up here and we look at angle 1 right here, and then we come down here and we look at what angle down here, 5, 6, or 7, 5, 6, 7, or 8, is in the same position as angle 1 up here. Well, what we do up here is we go, at this point of intersection, we go up and left. So we come down here and we go up and left. Well, angle 1 and angle 5 are in what we call corresponding positions, so those are corresponding angles. Now we're going to talk about interior versus exterior here in a second. Interior would be the guys that are on the inside of my two lines. These guys inside here are interior, and then these guys out here are my exterior guys, and down here. Now, when we are doing corresponding angles, look, one of them is on the inside and one of them is on the outside, and they are both on the same side of that transversal. In this case, they're both to the left of the transversal. One's interior, one's exterior. Alright, so now looking at that, let's go to angle 2 over here. what angle is in the same position as angle 2 is up here? So we go to the right of the transversal, we go up and right, up and right. So angle 2 and angle 6 are corresponding angles. Okay, let's get the rest of them. We actually have 4 pairs of these. So let's go to angle 3. Now this one's interior, so we've got to go to the exterior down here to the left, 3 and 7, and then 4 and 8. So right here I have 4 pairs of corresponding angles. Now, alternate interior angles are exactly what they sound like. They're angles that are on the interior on alternate, and when you hear the word alternate, you're thinking opposite, okay? So they're on the interior on opposite sides of the transversal. So instead of being both on the left, one's on the left, one's on the right. Now again, we're talking about interior angles, so we can ignore 1 and 2. We can ignore 7 and 8. They're irrelevant here because they're exterior. Alright, so let's look at angle 3. We'll start with angle 3 right here. What is the alternate interior angle with angle 3? Well, we got to go to the other intersection on the opposite side of the transversal, so that would be 3 and 6. Alright, so angle 3 and angle 6 are alternate interior angles. Alright, let's look at our other pairs. So 3 and 6 were, 4 and 5 are our other pair. So those are our alternate interior angles. Let's go to alternate exterior angles. Alternate exterior angles are exactly what they say. They're at the outside, the exterior. So now we're looking at 1, 2, 7, 8. We can ignore these 4 inside there. Okay. On alternate sides, so on opposite sides of the transversal. So if we're looking at 1, that's on the left side. We come down here, look at the exterior guys. This was on the left. Go to the opposite side, 8. So angle 1 and angle 8 would be alternate exterior angles. Alright, so let's do our other pair. We're going up here to the other exterior angle would be 2. Go down here to the opposite side. This was on the right. This is on the left, so it would be angle 2 and angle 7. Those are alternate exterior angles. Now notice, for corresponding angles, we actually had 4 pair. Here we only have 2 pair. Here we have 2 pair. Right. Now let's go to the same side interior. Same side interior is exactly what it sounds like. It's on the interior. Now instead of being on alternate or opposite sides of the transversal, the same side are going to be on the same side. So again, we're looking at interior, so we can ignore 1, 2, 7, and 8. We're looking on the interior. Let's go 3. What angle is on the same side as angle 3? So that would be 5. So angle 3 and angle 5. And our other pair would be 4 and 6. Now notice on each of these I have some shorthand here. Like we did VA and LP for vertical angles and linear pair, corresponding would be CA. Alternate interior angles, AIA, AEA, and SSIA. Those are just some abbreviations, some acronyms for these angle relationships. All right. So let's go through this. We want to use the drawing to the right to name all pairs of angle relationships given. So we want to name the transversal in this. Now, I forgot this guy should be C. This should be A, B, and C. Name the transversal that we're really worried about here, the one that gives us our 8 angles. That would be line C. Now what you have to remember is A and B are going to be transversals, but we don't know anything about their intersection out here, so we really don't care about those as being transversals. We'll just stick with line C. So we want to name all the pairs of corresponding angles. Now I'm going to start with angle 1 right here. Remember, corresponding angles are angles that lie in the same position. So to get this guy, we went up and to the right. So go down here, we go up and to the right. That would be angle 1 and angle 5. All right, that's one pair. Now let's go to 2. So we went up and to the left. Come down here, up and to the left would be 6. We'd have angle 2 and angle 6. 3, we've been down left. Come down here, down left. 3 and 7. And then that would leave us with angle 4 and angle 8 as being corresponding angles as well. Now let's go to alternate interior angles. Alternate interior angles are on the interior on alternate sides of the transversal. So we're not worried about 2, 1, or 7 and 8. 3 and 5. And then 4 and 6. So angle 4 and angle 6 are my 2 pair of alternate interior angles. All right, let's go to alternate exterior angles. So now we're looking at 1, 2, 7, and 8. We could ignore 3, 4, 5, 6. Alternate exterior, if I go to angle 1, we got to come down here and go to the alternate side, would be 7. So angle 1 and angle 7 are alternate exterior angles. And then we would go angle 2 and angle 8. Alright, now let's look at same side interior angles. Same side interior, we can ignore those two and those two. And we are looking at the interior, so that would be 3 and 6 would be all same side interior, angle 3 and angle 6. And then angle 4 and angle 5 would be same side interior angles as well. Now, if the measure of angle 1, so now I'm giving you some angle measures here, so let's go ahead and write those in the drawing. If the measure of angle 1 is 122 degrees, we are done up here. We don't need any other measures. We can calculate all of these. Now, the thing about this is I can't do anything down here yet because I don't know anything down here. Alright, so what we can do is angle 1 is 122. That means angle 3 is 122 as well. Now, if I asked you to explain that, you would simply say, hey, vertical angles. Those are vertical angles. Now we can go to angle 2. So to get angle 2, remember that's a line, that's a linear pair. So we would take 180 minus 122 and we would get 58. So this guy would be 58 degrees. Now if I asked you to explain that, you just say, hey, that's the linear pair postulate, LP. And if this is 58, this guy is 58 here. We could get from there with vertical angles, or we could do the linear pair here as well. Okay, so there's all those. Now we had to know that 122. So we had to know one up here to find that. Now we also know one down here, and they said, hey, this is 65. Because I know another one down here, I can find all these as well. So 65, this guy over here is 65 degrees. That's the vertical angle theorem. And then these two guys, we take 180 minus 65, and we get that that's 115. So this guy here is 115, and this guy here is 115 degrees. Okay, so we have both those angles there. All right, now what we can do is we can go on to the next problems here. These are not on your sheet, but I'm just going to go through these with you. What we have here is we're going to describe the relationship between 1 and 2. So we need to look. This is the interior. These are both exterior. So it's not CA, it's not AIA, it's not SSIA. They are on exterior, on opposite sides of the transversal, so these are AEA. These guys over here, now notice on this is the questions, these are the questions we need to ask ourselves. We look, are they both interior, they're both exterior? In this case, one's interior, one's exterior. Well, if one's interior and one's exterior, it leads you to corresponding angles, so what you need to check is, are they in the same position? Up and right, yes. These would be corresponding angles. Now let's go here. Again, ask yourself, are they both interior or both exterior? In this case, they are both on the interior. Now look, are they on the same side or are they on alternate sides? Well, they are on alternate sides, so these are on the interior, on alternate sides, so those are AIA. Right? Number 9, look, are they both interior, both exterior? In this case, they're both interior, so then ask yourself, are they same side or alternate sides? They are same side, so this would be same side interior angles. Right? If you need more examples, you can come see me. All right, now let's get on to the next thing. So now notice in the drawing that none of the lines are parallel. Let's see what happens when they are parallel. So if we draw two lines that are parallel, now to draw lines that are parallel, what I told you to do is go ahead and measure 2 centimeters apart. So from this line, you'd come down here and you measure 2 centimeters and you make a little point. You'd come over here, you'd measure 2 centimeters down, you'd make a little point. Now what happens, you need 2 points to determine a line. You can draw a line through those, and anywhere in here, those are going to be 2 centimeters apart, and hence those two guys are going to be parallel and will never intersect. Okay. Now what I ask you to do is go ahead and put your protractor on there, and I want you to draw this to intersect at a 60-degree angle. So what I'm going to do is I'm going to use my inside measurement here, and I'm going to go, alright, here what you would do is you would put your point on there and you draw your little pencil mark inside there to get your vertex, and then you come out here and you start counting. 10, 20, 30, 40, 50, 60, and then what you can do is come out here and at 60, make your little mark. Okay, here's your little mark right there. And then what you can do is with those 2 points is you can go ahead and draw your line through there. Okay. Now what will happen here, once you do that, This angle right here is what you measure to be 60 degrees, okay? You know this is 60 degrees, and you know the other two with your linear pair posted are 120 degrees. Now, I said on the last one we had to have an angle up and an angle down. You know, we needed to know this one, this 122 up here, we could find them all. We had to know this 65, and we could find them all. But on this guy, because these lines are parallel, now let's show they're parallel. Let's use those little symbols there. Because these two guys are parallel, I'm going to take a wild guess what happens down here. Because this is 60, this guy is 60, and this guy is 60. And then these two guys are going to be 120. Now that only happens when you have parallel lines. Once you have parallel lines, that's when this happens. I always like to show the lightning bolt. What happens here is all these acute angles falling down the lightning bolt are congruent, and then all these obtuse angles following that lightning bolt are congruent as well. Well, now if you look at this, what can you say about corresponding angles? Well, let's go corresponding angles. Upright, upright, 1660. Up left, 120, 120. Well, corresponding angles, once we have parallel lines, corresponding angles are going to be congruent. What about AIA? AIA, congruent. What about AEA? All the way over to here, all the way over here. Those two guys are congruent as well. Now, here's the trick to this. Here's the tricky part. What about SSIA, the same side interior? That would be these two and these two. Those aren't congruent. One's obtuse, one's acute. But if you add those two guys together, that's 180, that's 180. Now our math word for that is supplementary. Again, this will be the last time we see that word because, again, if we do this, watch what shape I create right here. Let's say I draw this guy as parallel to this guy. So these two guys are parallel now. What we created inside here is a little parallelogram. How about that? So we'll see that stuff again. All right, now here's the theorems for this chapter or for this section. We have the corresponding angles postulate. It simply states that if parallel lines are transverse, then corresponding angles are congruent, and they are. That's the way it's got to be. So these two guys are congruent, these two guys are congruent, and then these guys, that guy, those are vertical angles, those corresponding, and those are. Okay. All right. So alternate interior angles. If parallel lines are transverse, then alternate interior angles are congruent. Alternate exterior angles theorem. If parallel lines are transverse, then alternate exterior angles are congruent. And same side interior, this is the guy that changes. This is the guy that messes people up every year. Same side or supplementary. Same side or supplementary. So what you can do is you can pause this video and you can jot these theorems down. Alright, now what we're going to do is we're going to use the drawing to find the missing angle, and we need to explain our answer. So angle 4, if this angle right here is 57, then this angle right here is also 57. Now our explanation for that is the fact that we have, or those are corresponding angles with parallel lines. Now that's what the corresponding angles theorem states. Now if we go to angle 2, because this guy right here is 57, this guy right here is going to be 57 as well. Now the quick, short way to explain that is what's the relationship between this guy and this guy? Well, those are alternate exterior angles. We know that alternate exterior angles are congruent when we have parallel lines. Okay, let's go to angle 6. So now we look at angle 6. Angle 6 is also 57. Now to explain that, we got to go old school right here. That's 57 degrees. These two guys are vertical angles, so we just use the vertical angles theorem to explain that. Now, number 7, angle 7, these two guys form a linear pair. So if this is 57, 180 minus 57 would be 123. So that's 123, and to explain that, that would be the linear pair. Now, to finish this, let's go on to the next ones here. We're going to go to these big guy problems. We're going to use the relationships we know to find these angles. Now, if we look at these two guys are corresponding angles, so they are equal. So our equation would be 3x minus 10 equals x plus 40. On these two guys are same side interior angles, so our equation would be 2x plus x plus 75 equals 180, and then we could solve that, find x, and that would be the value of x. Now in this guy, if this is 90, all these are 90, and because these guys are parallel, All these guys are going to be 90 as well, so your equation here would be 2x minus 10 equals 90. Same process here. These two guys would be equal. Those are alternate exterior, so you'd have 10x minus 50 equals 5x plus 35. And then these guys, same side interior, so we would add them together. Same side interior is supplementary. Add those two guys together, and that would equal 180. Same process here. That would be 90, and then we could solve those. So that's lesson 3.3 and 3.4. If you do have any questions, especially on these big point problems here, which I kind of just got the equations going, and then you solve them on your own, come in and let me know if you do have any questions. Thank you.